Intro to questions 3 and 4. The expression square root b squared minus 4ac in the quadratic formula helps you understand the nature of the quadratic equation. The discriminant, which is b squared minus 4ac, of a quadratic equation gives information about the number of real solutions as well as the number of x-intercepts of the related quadratic function. Equation: x squared plus 2x minus 8 equals 0. It wants to know what is the discriminant. So what is b squared minus 4ac? So b is 2, so we have 2 squared minus 4 times a, which is 1, times c, which is negative 8. So 2 squared is 4 minus, this is going to be negative 4, positive 32. So it's going to be plus 32. So my discriminant is 36. Let's take a look at the discriminant of this one. We have x squared plus 2x plus 1. So we're going to have 2 squared minus 4 times 1 times 1. So this is going to be 4 minus 4, which is 0. Let's take a look at the discriminant here. We've got 2 squared minus 4 times 1 times 5. This is going to be 4 minus 20. 4 minus 20 is negative 16. Okay. Now remember, that's all under the square root, right? The rest of this is negative b. So in this case, that would be negative 2 plus or minus. What is the square root of 36? 6. All over 2 times 1, which is 2. So negative 2 plus 6 is 4. And 4 divided by 2 is 2. Negative 2 minus 6 is negative 8. And negative 8 divided by 2 is negative 4. So we have 2 and negative 4. How many real solutions are there? 2. How many numbers of x-intercepts should there be? 2. We're going to have an x-intercept at positive 2, an x-intercept at negative 4. Halfway between that would be negative 1. If I plug negative 1 into this equation, we would have, do this in pencil, negative 1 squared plus 2 times negative 1 minus 8 equals 0. So that's going to be 1. This should say 1 minus 2 minus 8 equals not 0. This is going to be negative 1 minus 8, which equals negative 9. So that ordered pair is negative 1, negative 9 is my minimum. Negative 1, negative 9 would be right about here. So it's going to look like such. Something along those lines. All right. So remember, this is my square root. So I've got negative 2 plus or minus 0 all over 2 because b was 2 and my a was 1. Well, negative 2 plus 0 is negative 2, and negative 2 divided by 2 is negative 1. Then we would have -2 minus 0, which is -2. -2 divided by 2 is -1. So how many real solutions do we have here? 1. So I know that I have a 0 at -1. We know that this opens upwards. I'm going to have to find 2 more ordered pairs here. Let's plug in 0 into this equation. 0 squared plus 2 times 0 plus 1 equals 0 plus 0 plus 1, which equals 1. So there's an ordered pair at 0, 1. So that would be here. But remember that it would be symmetrical. So at -2, 0, there would also be, -2, comma 1, there would be an ordered pair. So this would look something like this. Like such. Okay. Let's take a look at this one. This one we would have -2 plus or minus the square root of -16 all over 2 times 1, which is 2. My problem is I can't take the square root of -16. So this would actually be no real solution. So there would be 0 real solutions and 0 x-intercepts. Let's plug in some numbers here. If I plug in 0 here, I'm going to have 0, comma 5, because this would be 0, this would be 0. So 0, 5 is an ordered pair. Let's try 1. This would be 1 squared plus 2, so that's 3. That's going to be 8. Let's try -1. -1 would give me 1 minus 2, which is -1. And -1 plus 5 is 4. I haven't found my minimum yet. Let's try -2. This would be 4 minus 4, that's 0, plus 5, which is 5. No, that would be 4 minus 4 is 0. 0 plus 5 is 5. Okay, so here's my minimum. Because I've got -1, comma 4. I've got -2, comma 5. I've got 0, comma 5. And then we also had 1, 8. So that means there was probably a -3, 8 if I'd have continued the pattern out. So it looks like such. So notice that this has no x-intercepts. It never even touches the x-axis. Express regularity and repeated reasoning. Complete each statement below using the information from the table in item 3, sorry. If b squared minus 4ac is greater than 0, the equation has blank real solutions, and the graph of the related function has blank x-intercepts. So it says greater than 0. Well, that would have been this one, and that gave me 2 and 2. What if it equaled 0? If it equaled 0, we had one real solution and one x-intercept. That means that's my vertex. And if it was less than 0, that was where it doesn't touch the x-axis at all. So it has 0 and 0. Or you could have put no. Go ahead and copy the rest of this down. Make sure that you fill in your blanks for the vocab check on the next slide and mark this presentation as done when you've completed.